Hey guys, I'm making this video to demonstrate my project, a diaphragm valve in SOLIDWORKS, and to just give you an idea of how I made it. A diaphragm valve is unique because the mechanical actuator is completely isolated from the fluid flow, which is very important in biomedical engineering. Why? Because you want to prevent contamination. For this project, I have focused on the housing and the external assembly only, according to the relevant standards. Now, when it comes to 3D modeling, SOLIDWORKS offers some advantages over AutoCAD. I'm going to highlight those as we walk through the model. Okay, so to start, notice that in SOLIDWORKS, we can choose to work in a part file or an assembly file. Assembly is where we align individual components to build the final functional product. Okay, so let's jump into my assembly. This is the final model, and I can easily toggle between different view planes or orientations to inspect the geometry. One of the most powerful features here is the section view tool. It allows us to cut into the model in real time to inspect the internal fluid path, in my case. In AutoCAD, creating a section often requires manual trimming and tedious commands, but here it's just like this, instantaneous. You can just do it. Alright, now if you look at the design tree on the left, you'll see every part that is used in this assembly. Let's open the body part and let's see how it was built, okay? This tree is essentially a history of my design. I started with a simple rectangular sketch for an extruded boss, followed by extruded cuts for the internal bore. Finally, I applied fillets to the edges. They eliminate dead zones, where bacteria could accumulate. Unlike AutoCAD, I can travel back in time. I can just roll it back up, and if I do that, I can see each stage of the construction, which makes troubleshooting very intuitive. You can just hover over it and then you can see, right? It's very straightforward. Okay, let's go back into the assembly now. Mates are how we define the mechanical relationships between parts. In AutoCAD, you essentially glue parts together, right? But in SOLIDWORKS, that glue is logical. For example, if I suppress this coincident mate between the pipe and the body, the pipe can only move linearly along its axis. That's because I've applied a concentric mate to keep their centers aligned. Mates allow us to limit degrees of freedom in 3D space, ensuring the valve assembly behaves exactly like it would in the real world. Okay, so now let's look at the engineering drawings or data files that I made. This sheet is used to communicate design intent and dimensions. On the right, we have a view palette where I can simply drag and drop pre-made views onto the sheet. Under the Annotations tab, I use Smart Dimensions to pull the exact measurements directly from the 3D model. And now we have auto ballooning and the bill of materials. These are awesome. These features automatically label my components and link them to a table that tracks every part in the assembly. But the coolest feature is Bi-directional Associativity. What that means, that's a very difficult word, right? Don't worry about it. Let me show you. Notice the pipe length is currently 1.5 inches, right? If I go back to the part file from here and then change that to 2.5 inches, let me just do that. Okay, notice this. Okay, let's go back into the assembly now. The assembly recognizes the change immediately. If I check the datasheet again, the dimensions have updated themselves. Let's look. See, it's now 2.5 inches. Now that's crazy, right? In AutoCAD, a change like this might require redrawing multiple views, but here it's effortless. I don't even have to do anything. this workflow makes design light work. Like, I don't even have to worry about it, right? So that's just a quick look at how SolidWorks works. I hope this kind of gave you an idea on how it works compared to traditional drafting in AutoCAD. Thanks for watching, and have a good one.